is an endless fight. A battle for food and sex. But often the winning strategy is a balance of power. A truce between rivals. The same happens inside our bodies, where trillions of organisms have evolved to share us. There are worms in your bowel. Colonies of bacteria on your teeth. Fungi thrive in your lungs. And viruses embed themselves in your DNA. Collectively, this menagerie of bugs is called your microbiome. And it's as much a part of you as any of your organs.
We are essentially an assembly of a lot of different organisms, ourselves included.
Microbes have helped us to evolve. They've made us who we are.
They were there right from the evolution of human beings as hunter-gatherers, even right back to the evolution of mammals.
But in the blink of an eye, we've cut ourselves adrift from nature.
We've gone from a daily life in which we were exposed to thousands and thousands of species of many different kinds, where we ate food with dirt still on it, where we had worms, and then all of a sudden we move into these environments where we've convinced ourselves that all of their species, aside from our dogs and our lovers and our kids, are bad.
Believing it makes us healthier, we do our best to scrub bugs off our bodies. We've unleashed a war on germs, and now we are paying the price.
Modern medicine is about killing bad species. We are really good at thinking about medicine in that context. You know, something bad makes us sick, we kill it, we get better. But the idea that something good is missing and that makes us sick, we don't have much of a framework for that. The medicine that would be required to think about this in the right way would need to think about the body as an ecosystem.
In this revolution in medicine, it's the bugs that will save us. This is a journey into the human body. Your insides are a battleground, and it's your health that's at stake. Our tour begins at the mouth. All is not well with the main entrance.
Dental decay in this world now, I'm talking about all countries, is plague proportions.
Tooth decay now affects around 90% of children worldwide and can lead to serious diseases. It's an epidemic of the modern age. Compared to us, our ancestors had pearly whites. And they didn't even brush their teeth. It's a mystery that fascinated DNA detective Professor Alan Cooper. He's been studying teeth throughout the ages.
When you do look at the hunter-gatherer populations, you see very little signs of dental caries, the holes in your teeth. They look in really good nick.
But the closer we come to modern people, the worse the teeth become.
As soon as you start moving from the hunter-gatherer phase into the farming phase, the teeth look terrible. You know, there's dental caries, there's gum disease because of the bacteria around the base of the teeth, nasty pathologies.
And the consequences are far more profound than bad teeth. If Cooper could discover what's gone wrong inside our mouths, it might help explain the rise of some of our most serious diseases.
We think, oh, well, we get a bit of bleeding gums, we have to go to the dentist a bit, no big deal, we get holes in our teeth. What we don't realise is that the bacteria are leaking down through those inflamed gums into our blood system and stimulating all sorts of immune responses. And these immune responses are now being linked increasingly to a huge range of modern Western diseases: cardiovascular disease, diabetes, hypertension, premature birth, cancer. The list goes on and on.
In one way or another, the key to it all is bacteria. There are more than 100 million bacteria in every drop of saliva. An ecosystem of 700 different species. And there is no place they like better than the wet surfaces of our teeth. Here they form a layer, or biofilm, that dentists call plaque.
It happens every night when we're sleeping. The plaque, the layer of bacteria on our teeth, gets calcified and slowly builds up over time. This is what the dentist is removing.
We provide bacteria with a home, which is just as well, because without them, we'd have no teeth. The microbes in our mouth protect us from the food we eat.
We have evolved in the presence of acids. Most foods that we eat, most of our diet is essentially acidic. At the same time, the enamel, which makes up the outside surface of the tooth, is inorganic and will dissolve in acid. So here we've got this conundrum trying to work out, well, what's happening here? How does a tooth stop from dissolving?
The answer is biofilm, a dense layer of bacteria that's stuck on our teeth. As acid eats away at the enamel, bacteria fills in the holes.
The tooth starts to dissolve, then the raw products of this process get caught into the biofilm and in the right environment get reused to heal the tooth.
In a healthy mouth, everything works in balance, and the good bacteria protects us from decay. These microscopic dentists have looked after our teeth for much of our evolution. So what's changed?
We can only judge that if we've got an idea about what it looked like beforehand.
But there was a problem. There's no bacteria left alive on the teeth of museum skulls.
There seemed to be no way that we could actually get a look at what a bacterial microbiome would look like in the past until we thought about this calcified plaque on the teeth.
It was an ingenious solution. Locked in the plaque of our ancestors were the fossilized remains of vast numbers of bacteria. And compared to us, there was a striking difference.
Everything goes completely strange when the Industrial Revolution comes in, 1850, and suddenly you're getting large amounts of processed sugar and flour become available. And at that point, the diversity of the bacteria in the mouth just drops away. And huge amounts of these pathogenic bacteria become very obvious in everybody we look at.
A bunch of disease-causing bacteria has taken over our mouth. They thrive on our modern diet of processed food, and that's changed the game.
These organisms tend to be little acid factories, producing acid onto the tooth surface, which then starts to dissolve the enamel away and lower the pH of the environment, and they are able to withstand that low pH, that harsh condition that other microbes in the mouth aren't.
The good bacteria that don't like living in acid conditions, good bacteria that normally keep the bad bacteria under control, just like in the gut, then these die off.
Our changing diet unleashed a war inside our mouth. And the bad guys are winning. Acidity in our mouth is a problem, but there's one place where we couldn't do without it. Our stomach.
It's a filter that kills lots of pathogens. We eat food full of microbes, and one of the reasons those don't just colonize and take over our gut is that we have this stomach with adaptations for dealing with the microbes.
In fact, healthy humans can eat just about anything because 99% of the bacteria in your food are killed by the stomach acid. It's certainly enough to dissolve nails, and you have these stories over the years of people who try to kill themselves by eating razor blades or nails, etc. And a few months later, you look in their stomach and you can only find a few old rusty fragments. It's almost totally digested.
The only bacteria that survives the acid bath is the bug called the gastric demon, Helicobacter pylori.
Helicobacter is very, very interesting. It's somewhere in between a harmful one and a harmless, beneficial one.
No one knows this bug better than Australian Barry Marshall. In 2005, he shared the Nobel Prize with Robin Warren for discovering its power over us.
The reason people didn't look for bacteria in the stomach before the 1970s, when Dr. Warren first saw them, was that they knew that bacteria could not live in acid. It's too dangerous.
But we now know some bacteria have learned to survive in extreme environments. And the gastric demon is one of them.
So the question is then, how do bacteria survive in acid? And the next discovery was that the bacteria can make ammonia, and ammonia neutralises acid.
Helicobacter has a nasty reputation. It's called the gastric demon for a reason. It causes stomach cancer and gastric ulcers. Marshall and Warren were the first to show that ulcers weren't triggered by stress or spicy food as it was commonly thought, but by infection with Helicobacter.
However, we could never get over this issue that lots of people had the bacteria and never got an ulcer, and so the skeptics could always say, you must be wrong, because I have lots of people with Helicobacter and they never had a day's illness in their life.
And even more puzzling is that in the developing world, where the gastric demon is rampant, hardly anyone gets ulcers. Somehow, a dangerous bacteria for the rich is harmless for the poor. And the difference between the two is another parasite: worms.
Helicobacter pylori causes ulcers. If you don't also have parasitic worms, you can't just have a part of the ecosystem. You need the whole ecosystem.
It's all a question of balance. The proportion of worms and bacteria needs to be just right for a healthy body.
But just to show how subtle all of this is, if you remove Helicobacter pylori, which is what we're doing nowadays with antibiotics, we get another problem.
The eviction of Helicobacter in the Western world has contributed to the rise of new diseases, like asthma and allergies.
So it's in this gray area. It causes cancer, ulcers, possibly prevents asthma, but the reason it prevents asthma is possibly more important than all the terrible things it does.
Helicobacter is an invader that keeps our immune system busy. And if it's not present, we can overreact against harmless stuff like pollen or pets.
If you could find the correct strain, which you could control, then I think it would resurrect Helicobacter as a useful bacteria.
If we could tame the gastric demon, it might become a live vaccine against allergies.
So I think there are all kinds of possibilities. I'm quite excited about it. And we are already testing Helicobacter products in human volunteers at the University of Western Australia.